Okay, so today we'll solve GATE 2021 question. This is a question from real analysis or calculus. It's a question number 40. So it is saying that let the equation xy minus z log y plus e to the power xz equals to 1 can be solved in a neighborhood of the point 0, 1, 1 as y equals to f of x comma z for some continuously differentiable function f. Then you have to find the gradient of f at the point 0, 1. You have to check which one is correct. Okay, so this is the NPTEL reference. This you can also check. Okay, so let's try to solve. So this is saying that this implicit equation, it is saying that can be solved in a neighborhood of this point as a function of y as a function of x comma z. So basically implicit function theorem gives us this kind of, that when you can solve something in terms of the other variable. Okay, so let me first recall what implicit function theorem. Let me first write down what it is. Xy minus the equation is given xy minus z log y plus e to the power xz equals to 1. This can be solved in a neighborhood. So can be solved in a neighborhood of 0, 1, 1 as y equals to f of xz, right? So basically implicit function theorem gives when you can solve one variable in terms of others. So let me write the implicit function theorem. So implicit function theorem so I am writing it in general. Let f from some open set omega to Rm be a C1 function, means continuously differentiable function, on the open set omega, which is omega n cross omega m of this is the open set in Rn plus m, such that f of ab comma 0 for some point ab in omega. So if determinant of this del f by del y, so del f by del y, now it's with respect to y, it's a function from Rm to Rm. If this determinant is non-zero, then there exists a neighborhood ua cross ub of ab, of that point ab in omega, and a C1 function f from ua to Rm such that f of x comma fx is 0. on the neighborhood UA and FA is B. Right, so this is the implicit function theorem. So it is saying that if this is a, suppose a C1 function is given on an open set omega n cross omega, and at some point f of AB it's 0, and saying that let del f by del b, so f with respect to when we differentiate y, so we are viewing at a function from omega m to Rm, means the linear transform, this is a linear transformation, it's a m cross m matrix, so determinant is well defined. If it is non-zero, then there exists a neighborhood UA cross UB in omega and a C1 function such that f of x comma fx is 0. Means in that neighborhood where this derivative is non-zero, so here the del f by del y is non-zero, so second coordinate y you can write as a function of x, right? And fa is fb. So where which derivative is non-zero, so that variable you can write in terms of the other, right? So here we have this, here let define f of x y z to be xy minus z log y plus e to the power xz minus 1. So here we have solved, we can, this can be solved at the point 0 1 1 as y as a function of xz. So for that we need to check that del f by del y should be non-zero. So let's check. So as this can be solved as y equals to f of xz. So let's check del f by del y. What is del f by del y? Del f by del y means partial derivative with respect to y, so it is x minus z by y, so this only. Then del f, so del f by del y at the point 0 1 1, it will be 0 minus 1 by 1, so it is minus 1, so it is non-zero, right? So y can be solved as a function of xz, so it's fine. And what, right, now we have to find the gradient of y. So to find gradient of this small f, right, so this is basically y, so gradient of f at some xz point means this will be basically del f by del x small f comma del f by del z, and as y is f is basically y, so basically dy by del y by del x, this is del y by del z, right? So that we have to find. So this is grad f. Now we have, okay, so let's find what this is. And what we have also, we have f of 0 1 xz is 1, right? So what is the equation we have? This is the equation. This is the equation we have: xy minus z log y plus e to the power xz equals to 1. So this we can differentiate with respect to x. So differentiating with respect to x, we get, so differentiating with respect to x, what you will get? Y minus, so y is a function of x. So first when you differentiate with respect in x, you will get first derivative of x is 1, so y plus x del y by del x, as y is a function of x and z, minus, so z is independent variable now, and if you differentiate this, you will get, so this will get z by y del y by del x, and xz, if you differentiate with respect to x, so you will get plus z e to the power xz equals to 0, right? Or so x minus z by y del y by del x is minus y minus z e to the power xz, or so what will be del y by del x? So del y by del x will be minus y plus z e to the power xz by x minus z by y. So if you simplify, what you will get? Y square plus yz e to the power xz by z minus xy. So del y del x we got. Now we have to find del y del z. So now we will again differentiate this with respect to z. Now differentiating with respect to z, we get, so if you differentiate with respect to z first, what you will get? First, y is a function of z, so x, so let me write the first equation here, as this is xy minus z log y plus e to the power xz equals to 1. So differentiating with respect to z, we'll get x del y del z minus log y minus z by y del y del z plus x e to the power xz equals to 0. Now as early, collect the term for del y del z. So log y minus x to the power xz, or del y del z log y minus x to the power xz by x minus z by y. So y into log y minus x to the power xz by xy minus z. So therefore what is the gradient? Therefore gradient of f is, so del y by del x, this is y square plus yz, y square plus yz e to the power xz by z minus xy, and this one is y into log y minus x to the power xz by xy minus z. Now we have to find gradient at the point 0 comma 1, right? So gradient of f at 0 comma 1, and f at 0 comma 1 is basically 1. So put x equals to 0, basically this. Means x equals to 0, y equals to 1, z equals to 1. So if you put it here, what you will get? y1, so it's 1 plus yz1, so it's 1 by z1, comma y is 1, log y is 0 minus, so it's 0. So it's 2 comma 0. So gradient at the point 0 comma 1 is 2 comma 0. Okay, so this is the answer. So therefore which answer is correct? So 2 comma 0. So therefore option number A is the correct one. Okay.